Question 1. For a reaction A plus B gives products, it was found that rate of reaction increases 4 times if concentration of A is doubled, but the rate of reaction remains unaffected if the concentration of B is doubled. Hence, the rate law for the reaction is. Now, from the given things, I can understand that the rate does not depend on concentration of B. Therefore, rate will be equal to K A raised to X. As A is doubled, the rate of the reaction increases 4 times. So, R2 will be equal to 4 times R1. R1 will be equal to K concentration of A raised to X. R2 will be equal to K concentration of 2A raised to X. R2 upon R1 will be equal to K 2A raised to X upon K A raised to X. Here I will get 2 upon 1 the whole raised to X equals to 4. Therefore, X will be equal to 2. Question 2. In a first order reaction, the concentration of reactant decreases from 800 mole per dm cube to 50 mole per dm cube in 2 into 10 raised to 2 seconds. The rate constant of the reaction in per second is. Rate constant is given by the formula K equals 2.303 upon T log to the base 10 A upon A minus X. Here T is given as 2 into 10 raised to 2 seconds. A is given as 800 mole per dm cube. A minus X is given as 50 mole per dm cube. So K equals 2.303 upon T log to the base 10 800 upon 50, which comes out to be 2.303 upon 2 into 10 raised to 2 log to the base 10 16. K equals 2.303 upon 2 into 10 raised to 2 log 2 raised to 4 to the base 10. 2.303 upon 2 into 10 raised to 4 into 4 into 0.3010, which will be equal to 1.38 into 10 raised to minus 2 per second. Question 3. A reaction that is of the first order with respect to reactant A has a rate constant 6 per minute. If we start with concentration of A equals 0.5, when would concentration of A reach the value 0.05? K equals 6 per minute. Small a equals 0.5 mole per liter. A minus X equals 0.05 mole per liter. Here T will be equal to 2.303 upon K log to the base 10 A upon A minus X. 2.303 upon 6 log to the base 10 0.5 upon 0.05, which equals 2.303 upon 6 into log 10 to the base 10, which would be equal to 0.384 minutes. Question 4. For any reaction, if we plot a graph between time t and log of A minus X, a simple line is obtained. The order of the reaction is. Now let us consider the equation for first order. T equals 2.303 upon K log A upon A minus X. On simplifying this, I get Kt upon 2.303 equals log A minus log of A minus X, which can also be written as log A minus X equals log A minus Kt upon 2.303. Now this equation represents y equals C plus mx, where the slope here is minus k upon 2.303. So this is an equation of a straight line. Therefore, a plot between time t and log of A minus X will be a simple line for a first order reaction. Question 5. In the synthesis of ammonia from nitrogen and hydrogen gases, if 6 into 10 raised to minus 2 mole of hydrogen disappears in 10 minutes, the number of moles of ammonia formed in 0.3 minutes is. Consider formation of ammonia. N2 plus 3H2 gives me 2NH3. Concentration of NH3 upon delta T would be equal to minus 2 by 3 concentration of H2 upon delta T. Minus 2 by 3 into 6 into 10 raised to minus 2 upon 10. Concentration of NH3 upon delta T would be equal to 0.4 into 10 raised to minus 2. Only concentration of NH3 would be equal to 0.4 into 10 raised to minus 2 into 10 as delta T is 10. So, in 10 minutes, the number of moles would be 0.4 into 10 raised to minus 1. In 0.3 minutes, the number of moles would be 4 into 10 raised to minus 1 into 3 upon 10, which would be equal to 1.2 into 10 raised to minus 3. Question 6. The order of a reaction with rate equals K Ca raised to 3 by 2, Cb raised to minus half. Now order for this would be 3 by 2 plus minus half. That will be 3 by 2 minus half, which will be equal to 2 upon 2, which will be equal to 1. Question 7. The order of a reaction occurring by following mechanism should be. Now, looking at the question, we understand that A plus B2 giving AB plus B is the slowest step. So that is the rate determining step. So R will be equal to K, concentration of A into concentration of B2 raised into Kc. Concentration of A would be equal to Kc raised to half, A2 raised to half. Therefore, rate would be equal to K into Kc raised to half, A2 raised to half into B2, which would be equal to K A2 raised to half, B2 raised to 1. So the order would be half plus 1, which would be equal to 1.5. Question 8. The rate constant for a second order reaction is 8 into 10 raised to minus 5 per mole per minute. How long will it take for a 1 molar solution to be reduced to 0.5 molar? Now for a second order reaction, K equals 1 upon T into 1 upon final concentration minus 1 upon initial concentration, which equals 8 into 10 raised to minus 5 equals 1 upon T, 1 upon 0.5 minus 1 upon 1. So from here, time would be equal to 0.125 into 10 raised to 5 minute. Question 9. For a first order reaction, velocity constant K equals 10 raised to minus 3 per second. 2/3 life for it would be. For a first order reaction, I know K equals 2.303 upon T log of A upon A minus X. In this case, your X equals 2/3 of A. Therefore, 10 raised to minus 3 equals 2.303 upon T log A upon A minus 2/3 of A. 10 raised to minus 3 equals 2.303 upon T log of 3. Therefore, time would be equal to 2.303 into 0.4771 upon 10 raised to minus 3, which comes out to be 1098.7 seconds, which is approximately 1100 seconds. Question 10. 75% of a first order reaction was completed in 32 minutes. When was 50% of the reaction completed? K equals 2.303 upon T log of A upon A minus X. Now, in the first case, 75% of the first order reaction was completed. Therefore, I can say K equals 2.303 upon 32 log 100 upon 100 minus 75. In the second case, 50% of the reaction was completed and time is what we are supposed to find. So K equals 2.303 upon T log 100 upon 100 minus 50. On dividing both the equation and solving them, you get T equals 16 minutes. Question 11. For a reaction system 2NO plus O2 giving 2NO2, volume is suddenly produced to half its value by increasing the pressure on it. If the reaction is of first order with respect to O2 and second order with respect to NO, the rate of the reaction will. Now, since the rate is given as second order in terms of NO and first order in terms of O2, I can write R equals K NO square O2 raised to 1. Now, as volume is halved, the concentration will double for NO as well as O2. Therefore, the new rate would be R dash equals K 2 times NO square 2 times O2, which on solving gives 8K NO square O2. On dividing R dash by R, you get 8K NO square O2 upon K NO square O2, which is equals to 8. Therefore, the new rate is 8 times the original. Question 12. The half-life of two samples are 0.1 and 0.4 seconds. The respective concentrations are 200 and 50 respectively. What is the order of a reaction? For any order reaction, the relationship between T half and A is given as T half is proportional to A raised to 1 minus N, where N is the order of the reaction. In this case, 0.1 upon 0.4 would be equal to 200 raised to 1 minus N, 50 raised to 1 minus N. 1 upon 4 would be equal to 4 upon 1 raised to 1 minus N. Therefore, 1 upon 4 will be equal to 1 upon 4 raised to N minus 1. So, N minus 1 equals 1. So, N would be equal to 2. Question 13. The rate of a reaction between two reactants A and B decreases by a factor of 4 if the concentration of reactant B is doubled. The order of the reaction with respect to reactant B is, rate would be equal to Kb raised to N, where N is the order. Now, when concentration of B is doubled, the rate decreases by a factor of 4. Therefore, 1/4 of R would be equal to K 2B the whole raised to N. 4 would be equal to half raised to N on dividing both the equations. Therefore, 4 equals 2 raised to minus N. Therefore, N would be equal to minus 2. Question 14. A first order reaction was started with a decimolar solution of the reactant. 8 minutes and 20 seconds later, its concentration was found to be m upon 100. So the rate of the reaction is. Now for a first order reaction, K equals 2.303 upon T log A upon A minus X. Since the initial concentration was decimolar, A would be equal to 0.1 m. The final concentration was m upon 100, so A minus X would be equal to 0.01 molar. Time taken is 8 minutes 20 seconds, which equals to 500 seconds. Therefore, K would be equal to 2.303 upon 500 log 0.1 upon 0.01, which equals 2.303 upon 500 into log 10. Therefore, K equals 0.0046, which can be written as 4.6 into 10 raised to minus 3 per second. Question 15. Which of the following is wrongly matched? A. Saponification of CH3COOC2H5 to second order reaction. Hydrolysis of CH3COOCH3 to unimolecular reaction. Decomposition of H2O2 to first order reaction. Combination of H2 and Br2 to give HBr zero order reaction. Now this is more of a factual question. So saponification of CH3COOC2H5 is actually a second order reaction. Hydrolysis of CH3COCH3 is correctly matched as a pseudo unimolecular reaction. Decomposition of H2O2 is a first order reaction. Now in case of H2 plus Br2, which gives you 2HBr, this reaction has an order equals to 1.5. Here it is given that it's a zero order reaction. That means this is wrongly matched. So option D would be your correct answer. Question 16. In a reaction, the concentration of reactant is increased 2 times. Then the increase in rate of the reaction was 4 times and 9 times respectively. Order of the reaction is. Now the question says, when concentration of suppose a reactant A is doubled, the rate becomes 4 times. When the concentration of a reactant is made 3 times, the rate becomes 9 times. So we can obtain a relationship as rate is equals to K into the reactant raised to 2, as when A is doubled, the rate is squared, and when B is tripled, again the rate is squared. Therefore this would be a second order reaction. Question 17. Hydrolysis of DDT is a first order reaction. Its half-life is 10 years. Time to hydrolyze 10 gram DDT to half is. Since half-life is given as 10 years, and for a first order reaction I know K equals to 0.693 upon T raised T half. Here T half is 10, so K would be equal to 0.0693. Initial concentration is 10 gram and final concentration has to be halved, so A minus X would be equal to 5 gram. T would be equal to 2.303 upon K log A upon A minus X, which equals 2.303 upon 0.0693 into log 10 upon 5. T equals 2.303 upon 0.0693 into log 2. So the final answer on solving this will be 10 years. Question 18. The rate of a first order reaction is 0.6932 into 10 raised to minus 2 mole per liter per minute. And the initial concentration of the reactant is 1 molar. Half-life is equals to. Rate is given as 0.6932 into 10 raised to minus 2 mole per liter per minute. Concentration of reactant is given as 1 molar. R equals K reactant raised to 1 since it's a first order reaction. So K would be equal to 0.6932 into 10 raised to minus 2. Half-life equals 0.693 upon K, which would be equal to 0.693 upon 0.6932 into 10 raised to minus 2, which equals 100 minutes. Question 19. In the reaction of 2N2O5 gives 4NO2 plus O2, initial pressure is 500 atm and the rate constant K is 3.38 into 10 raised to minus 5 per second. After 10 minutes, the final pressure of N2O5 is. Initial pressure is 500 atm. K equals 3.38 into 10 raised to minus 5 per second. K for a first order equals 2.303 upon T log to the base 10 P0 upon Pt, where P0 is the initial pressure and Pt is the final pressure. 3.38 into 10 raised to minus 5 equals 2.303 upon T log to the base 10 500 upon Pt. As time is given as 10 minutes, I can say log of 500 upon Pt would be equal to 0.0088. Pt would therefore be equal to 500 upon 1.02, which equals 490 atm. Question 20. The temperature coefficient for reaction in which food deteriorates is 2. Then food deteriorates dash times as rapidly at 25 degrees Celsius as it does at 5 degrees Celsius. Now, for an increase in temperature of 10 N, the rate increases by 2 raised to n times. Here, the increase in temperature is 20 degrees Celsius, that is 25 minus 5. Therefore, rate increase would be 2 raised to 2 times, which should be equal to 4 times. Question 21. The rate of a chemical reaction doubles for every 10 degree rise of temperature. If the temperature is raised by 50 degrees Celsius, the rate of reaction increases by about. Rate at 50 degrees Celsius upon rate at some initial temperature T1 degree Celsius will be equal to 2 raised to delta T upon T1, which equals 2 raised to 50 upon 10. 2 raised to 5, which equals 32 times. Question 22. A graph plotted between log of K versus 1 upon T for calculating activation energy is shown by. Now from Arrhenius equation, I can say log of K equals log of A minus EA upon 2.303 RT. This equation represents y equals C plus mx, where m is the slope. So here the slope is minus E upon 2.303 R. Now since the slope here is negative and the equation represents a straight line, the graph would be a downward sloping line, log K on one side and 1 upon T on the other side. Therefore your answer would be option B. Question 23. The rate constant is double when temperature increases from 27 degrees Celsius to 37 degrees Celsius. Activation energy in kilojoules is log of K2 by K1 equals EA upon 2.303 R into 1 upon T1 minus 1 upon T2. Here K2 by K1 equals 2. Therefore, log of 2 equals EA upon 2.303 into 8.314. T1 is 27 degrees Celsius, which is 300 Kelvin. T2 is 37 degrees Celsius, which is 310 Kelvin. Therefore, EA would be equal to 2.303 into 8.314 into 0.3010 into 300 into 310 upon 10, which equals 53598.59 joule per mole, which can be written as 54 kilojoules per mole. Question 24. The rate constant is given by the equation K equals PZ e raised to minus E upon RT. Which factor should register a decrease for the reaction to proceed more rapidly? For the reaction to proceed more rapidly, K has to increase. K will increase when P increases, Z increases. Okay. If you see, E power is negative. Therefore, a decrease in activation energy will increase K, which will make the reaction faster. Therefore, your answer would be option C. Question 25. The rate law for a reaction between the substances A and B is given by rate equals K A raised to N into B raised to N. On doubling the concentration of A and halving the concentration of B, the ratio of the new rate to the earlier rate of the reaction will be as. Rate is given as K A raised to N B raised to N. A is doubled and B is halved. Therefore, I can say the new rate is K 2A raised to N B by 2 raised to M, which equals 2 raised to N upon 2 raised to M K A raised to N B raised to M. R dash would be equal to 2 raised to N minus M into R. Therefore, R dash upon R would be equal to 2 raised to N minus M. Question 26. The activation energy for a reaction is 9 kilocalorie per mole. The increase in the rate constant when its temperature is increased from 298 Kelvin to 308 Kelvin. Log of K2 by K1 would be equal to EA upon 2.303 R T2 minus T1 upon T2 into T1. Here, log of K2 by K1 would be equal to 9 into 10 raised to 3 upon 2.303 into 2 into 308 minus 298 upon 308 into 298. K2 by K1 would be equal to 1.63. K2 equals 1.63 into K1. Therefore, percent increase will be K2 minus K1 upon K1 into 100, which comes out to be 1.63 K1 minus K1 upon K1 into 100, which is equal to 63%. Question 27. The reaction X becomes product follows first order kinetics. In 40 minutes, the concentration of X changes from 0.1 molar to 0.025 molar. When the rate of a reaction when concentration is 0.01 molar for X. Now, concentration changes from 0.1 molar to 0.025 molar in 40 minutes. 0.1 molar to 0.05 molar would take one half-life. 0.05 molar to 0.025 molar will take another half-life. Therefore, 40 minutes represents two half-lives. So, half-life would be equal to 20 minutes. Therefore, K would be equal to 0.693 upon 20 into the concentration of X given, that is 0.01, which equals 3.47 into 10 raised to minus 4 mole per minute. Question 28. A substance undergoes first order decomposition. The decomposition follows two parallel first order reactions as follows. A decomposes to B with rate constant K1 and also decomposes to C with rate constant K2. K1 is given as 1.26 into 10 raised to minus 4. K2 is given as 3.8 into 10 raised to minus 5. Calculate the percentage distribution of B and C. Percentage distribution of B would be equal to K1 upon K1 plus K2 into 100, which equals 1.26 into 10 raised to minus 4 upon 1.26 into 10 raised to minus 4 plus 3.8 into 10 raised to minus 4, which is approximately 76.83%. Same way, percentage distribution of C would be equal to K2 upon K1 plus K2 into 100, which is 3.8 into 10 raised to minus 4 upon 3.8 into 10 raised to minus 4 plus 1.26 into 10 raised to minus 4 into 100, which equals 23.17%. Question 29. The rate constant K dash of one reaction is double of the rate constant K double dash of another reaction. Then the relationship between the corresponding activation energy of the two reactions, that is EA dash and EA double dash, will be: as K increases, activation energy decreases. Therefore, since K1, that is K dash, is greater than K double dash, I can say EA dash will be less than EA double dash. Question 30. The temperature dependence of rate constant K of a chemical reaction is written in terms of Arrhenius equation. K equals A e raised to minus E by RT. Activation energy E of the reaction can be calculated by plotting which of the following? Now K is equals to A e raised to minus E by RT. Taking log on both sides, I get log of K equals log of A minus E by RT. This equation represents y equals C plus mx. Here your slope is minus E by R. Since the slope is minus E by R, the line would be a straight line with negative slope. Therefore, the graph would look like where log K is on y-axis and 1 upon t is on x-axis, and the slope would be minus E by R.